Today I'll be going through my solution, and another more optimal solution for Leetcode 392 is subsequence. So given two strings s and t, return true if s is a subsequence of t or false otherwise. A subsequence of a string is a new string that is formed from the original string by deleting some, can be none of the characters without disturbing the relative positions of the remaining characters. For example, ACE is a subsequence of A, B, C, D, E, while AEC is not. And as we can see for our examples, we have this S and we have this T, and we return true because we have A, B, C, and we can get it in this order, A, B, and C. So it's a subsequence, and then we don't have it in this case because we don't have an X inside T. So I'll be going through my solution, which isn't the best solution to this problem, but it was my original solution, which was accepted. And I'll be going over a more optimal solution I got from a YouTube video, which I'll link in the description. So firstly, I guess my thought process behind this was I was really just thinking, okay, I need to make sure that we have the same elements within both S and T, and that they're in the same order. So that kind of was my thought process when approaching this. And I was thinking, okay, maybe I can just create an array, and each time I come across a value that's the same, I add it into the array. And after that, I say, okay, well, I know it also needs to be in order. So just in case the values I added were out of order, I didn't add the values, I added their indexes, and then I compared that with each other. And then what I did is I also used the length of the new list to see if I even had the same characters, because if I didn't have the same characters, then the length would be smaller. And that's essentially what I did to solve this problem. So firstly, I created something called IND, which is short for index. I made it a list, and I said found is equal to 0. Found is equal to 0, and that's something that we'll be updating later. So now I say, okay, for I in range for the length of S, I'm going to say that what we're looking for is going to be S at I. Then I say, okay, for J in range found length at T, we said that if S at J is equal to look, if T at J is equal to look, then we append the index to the index array. And then we say, okay, found is equal to J plus 1, and then we break. And so what I want to do after this, let me explain this a little bit, why I had found right here. So the reason I had found is so anytime I found something, there was no need to go through the entire string for T, because we know that we already want it to be in order. So if we found something and then the other character that we're looking for was before it, then we already know that it's not going to be something we're looking for. So this is just a way to optimize it. And so just in case we have duplicates, nothing really goes wrong with that. So we're always starting after what we already found. And then so I said, okay, well, if the length is not equal to the length of the index array, then I return false, because that means that there's a character that's missing. And I said, okay, for J in range, the length of S minus 1, I said that if the index at J is less than the index, is greater than the index at J plus 1, return false. And I said this because now I'm just checking the order, and I'm making sure that each index is increasing. And then if none of these false conditions happen, I can return true. And then I know that this was correct. So when talking about time for my solution, it may at first, maybe it might look like O of n times m, but because O of n being relative to s and m being relative to t, but that's not the case, because found, and what found does is each time it increases whenever we find something that we're looking for. So we're not reiterating over parts of the array, and at the worst case, we go through O of n plus O of m. And when talking about space, mine is O of n, because I end up creating this index array, and the index array potentially could be the size of S, as we always add characters to it for each character in S that we end up finding. Okay, so now I'll be going over the solution I found on YouTube. Right, so to start, we create two indexes or pointers, pointer S and pointer T, with respect to both of their arrays. And we iterate through using a while loop, and then we say, hey, if we end up reaching the end of S, or if pointer T ends up reaching the end of T, then let's break out of it. But if we do find that S at pointer S is equal to T at pointer T, then we increment S, and we will always increment T. And then we return, hey, is pointer S equal to the length of S? So the best way to visualize this would be through an example. So we're using the input that we're given over here. And so let's just go through it. So we know that both S and T, pointer S and pointer T, are going to start at 0. So then what we want to do is we want to say, hey, this is a statement right here. Is A and A the same? Yes, it's the same. So both shall increase. Then we say, hey, is H and B the same? No, it's not the same. So we know in this case only T is going to increase. So we increase T. Then we say, hey, is B and B the same? Yes, it's the same. So both shall increase. This one wants to increase as well. And then we say, hey, is this the same? No, it's not. Just increase T. Oh, right there. And we say, hey, are they the same? No, they're not. So increase T one more time. And we say, hey, are they the same? Yes, they are. So S will increase first, and then T will increase. Let me make this a little bit more. Yeah. So basically, if you want to think about this conceptually, what you're doing is you're referencing both arrays. And what you do is every time you come across the value that's the same, you're going to increase both T and you're going to increase S. And so at the end, you kind of use the length of S to say, hey, if the length is the same, then you know that nothing went wrong in that process of going through the array. But if the length was less, then you know that you got stuck somewhere. So either you didn't have a character, like a character was missing, or maybe a character was out of order. So I'll be going over like the character out of order right here. So let's reset our S and T. So we'll have a T, and we'll have an S. So we're going to say, hey, is A the same as A? Yes, it's the same. So let's go ahead and move T, and let's go ahead and move S. And then we say, oh, hey, is G and C the same? No, it's not the same. So let's go ahead and move T. Is B and C the same? No, it's not the same. So let's go ahead and move T. Is G and C the same? No, it's not the same. Let's go ahead and move D. Is D and C the same? No, it's not the same. Let's go ahead and move it. And we say, hey, is C and C the same? Yes, it's the same. Let's move this up. And then let's go ahead and move this up. So now we end up reaching this condition, hey, that pointer T is not less than the length of T, it's the same. So what ends up happening is that we go through this check, and then we check, hey, is pointer S equal to the length of S? And in this case, it is not. It's equal to 2, while the length of S is equal to 3. And that happened because we got stuck because our characters were mismatched. And when talking about both space and both time, in terms of space, the solution is a lot better than my solution, as it runs with O of 1 space, as we only create these two new variables, and you don't create any new array. And in terms of time, we do O of n plus O of m, because in the worst case, you have to iterate through this array fully, and you have to iterate through this array fully. So yeah.